So we are looking for the zeros of g from 0 to 2 pi. What is a zero of a function? Sometimes they are called solutions. Yes. It's where it crosses the x-axis, or we could call it an x-intercept. And at an x-intercept on a graph, what do you know about that point? About the coordinates of that point? The y is always 0. The x could be anything, but the y is always 0. So, if I want to find the 0 of a function, then I can plug in 0 for the y, and in this case, your g of x is like your y right here. So I'm going to have 0 equals 3 minus 4, and I'm going to write it this way just for this first problem. Whenever we see sine squared x, that means that your sine of x is squared, right? So if I'm going to solve this, the first thing I would need to do is subtract the 3. So I'll get negative 3 equals negative 4 sine of x squared. And I would need to divide that negative 4. And that'll give me positive 3/4 equals sine of x squared. Everybody all right there? Okay, what am I going to have to do next? Square root both sides. So when I square root a fraction, I'm square rooting the top and the bottom. So if I take the square root of the top, I can't really do anything with that. It's just going to be the square root of 3. But if I take the square root of the bottom, what do I get? I just get a 2. So when you write that, you'll no longer have the square root on the bottom. The square root's only on the top, and that is good because square root of 3 over 2 is on our unit circle, right? That's a unit circle value, so that will make it easier to solve. And so I've got sine of x over here. Now, I forgot something. What did I do wrong? Or what did I forget? When I square root both sides of an equation, there's something I got to do. I've got to put a plus or minus over here. So when you square root both sides, we might even want to make a note about this. When we square root both sides of an equation, we must put a plus or minus there. So this is really two separate things. We're looking for where sine of x equals positive square root of 3 over 2, or we're looking for where sine of x equals negative square root of 3 over 2. It can be either one. So we'll be using our unit circle a lot, just like we were yesterday. On that unit circle, where does sine of x equal square root of 3 over 2? Okay, pi over 3 right here, and 2 pi over 3. So we'll get x equals pi over 3. As an answer, we'll get x equals 2 pi over 3 as an answer. What about negative square root of 3 over 2? 4 pi over 3 and 5 pi over 3. And those values there just coming from our unit circle. Okay, this is restricted to 0 to 2 pi, so I would not put like a plus 2 pi k or anything here. It's just going to be those values. Okay. Similar to what you were doing last night, but you got that square, so you got to square root both sides. You got to put the plus or minus. So you're going to have more answers normally for those problems. Okay. Example 7. What are the values of theta for 0 less than or equal to theta less than 2 pi, where cosine squared theta equals negative cosine theta? So, any ideas on how to solve that one? Can I combine my cosine squared and my cosine? I cannot, because one of them is squared and one of them is not. It's like having an x squared and a regular x. I cannot put those together. It would be convenient to divide by cosine, because if we did, you might not want to write this down. If I divide by cosine, then I would get cosine of theta, right? I'd cancel out 1, and what would I get over here on the other side? Negative 1. The problem is dividing by a trig value or trig expression and canceling will usually cause you to lose an answer. So, if you do it this way, you will get some of the answers, but not all of them. Yes? If you did that, it will get rid of the one on the right. Actually, you need to get rid of that negative first. But inverse cosine of cosine squared will not get rid of one of those. Will not get rid of one of those cosines, because cosine squared is totally different than just cosine. So it would not get rid of one of those. So if you take a square root, you're going to have on the right side, you're going to have cosine theta underneath the square root, which means then you got to square it to get rid of that square root, which just squares the other side back, and you're just going to flip, flop, flip, flop, flip, flop. You'll never get anywhere for that. That I like. That is a good idea. So, instead of dividing by cosine, which will get you some of the answers, but not all of them, let's move everything to one side. Cosine squared theta plus cosine theta equals 0. It's a lot like having, pretend like instead of cosines we had x squareds. It's a lot like having x squared plus x equals 0, right? It's not, but it's similar there. What are we going to do now if everything's on one side? You can factor cosines. Factoring is what we're going to do. Like if we were over here, we would factor out a greatest common factor. We do x times x plus 1. We can do pretty much the same thing, but with cosines instead of x's, right? So we could pull out a cosine of theta, because this first one is cosine squared theta is cosine theta times cosine theta. We can just pull one of them out. And on the inside, we'll have cosine theta plus 1. Right here, make sure you've got that 1, because when you pull that cosine out, you got to have something left. There's a 1 in front of that cosine. It's got to stay there, because if it does not, you won't have that placeholder. If you try to multiply it back, you won't get the right answer. So you can factor with cosines. Basically, just treat it like it would be an x instead of a cosine. And so if I factor, then what do I do with the two things I factored out? What? What would I do if I had it at this point right here with x's? I'd have x equals 0 and x plus 1 equals 0, like that, and then that'd give me x equals negative 1. I'm going to do the same thing here. I'm going to do cosine theta equals 0 and cosine theta plus 1 equals 0. So, where does cosine of theta equal 0? pi over 2 will be one of our answers, and the other one from this part is 3 pi over 2. We're just pulling that from our unit circle. That's where our cosine's our x coordinate. That's where the x equals 0. Okay? Over here, what do I have to do to this second equation? Subtract that 1. Cosine of theta equals -1. Where does cosine of theta equal -1? Yes, pi. I had to think for a second there. And so pi would be the only place that happens. That is one of your answers. So you'll have 3 answers for this problem. So if you see in the problem that you have a trig function squared and another trig function that is not squared, you need to move everything to one side and factor. Okay? All right, questions? All right. Example 8 is going to be pretty similar. For example 8, they have worded this differently. It's not just asking you to solve an equation, but it's saying let f of x equal 2 sine squared x and g of x equal square root of 3 sine x. And what in the xy plane, what are the x coordinates of the points of intersection of the graph of f and g? So it's asking us about the intersection of the two graphs. What do we do if we want to see where two graphs intersect? We set them equal to each other. So what we'll do for this is we'll say 2 sine squared x equals square root of 3 sine x. And this is a lot like the problems that you were doing for the last couple on your homework last night. It was asking where you had those intersections, so that 15 and 16 were the same types of problems. But this one is going to be a little different than those because you got a sine squared and just a regular sine, right? So if I have a sine squared and a regular sine, what do I need to do? Everything to one side. So I will do 2 sine squared x minus the square root of 3 sine x, and that will equal 0. Okay, I need to factor that. How am I going to factor it? Pull out a sine x, because they both have sine x's. So sine x on the inside, I'll be left with 2 sine x minus the square root of 3. That'll equal 0. And now I can just set each one of those factors equal to 0. So this one is just going to be sine of x equals 0. The other one is going to be 2 sine x minus the square root of 3 equals 0. I'm going to add the square root of 3, which will give me 2 sine x equals the square root of 3. I will divide off that 2, so I get sine x equals square root of 3 over 2. And we want to know what the x's are, right? So where does sine equal 0? It does equal 0 at 2 pi. Should I use 2 pi as my answer? It's not in the domain because they don't have an or equal to here. So what else could I call 2 pi? 0. And do I have an or equal to with my 0? I do. So I'm going to call that 0 instead of 2 pi for this problem. And then where else does sine equal 0? Pi. Very good. Okay. Then I have to think about where sine x equals square root of 3 over 2. Where does that happen? Sine is your y coordinate. It is going to be pi over 3. And then you got another place. Where is it? 2 pi over 3. Questions? Now, in these notes, he did not give you one more type of problem I think we probably need to do. So let's look at number 20 on the worksheet you guys had last night. So let me open that up. Okay, so for this problem, we're still looking just from 0 to 2 pi. And it's asking us where cosine squared equals cosine theta plus 2. And so you'll see we've got a square and one that's not squared. So when that happens, it's like a quadratic. We need to move everything to one side and factor. When we do that on this problem, we are going to get cosine squared theta minus cosine theta plus 2 equals 0. How am I going to factor that? Does it have a greatest common factor? Like, could we pull out a cosine? What? Can I pull a cosine theta out of the 2? No. And you can't move the 2 over to the other side because this, like, the product property that we're using, the 0 product property, only works if this equals 0. Like, if I have cosine of theta times cosine of theta minus 1 equals negative 2, I cannot say cosine of theta equals negative 2 and cosine of theta minus 1 equals negative 2. That would be wrong. Because what you're using is the 0 product property, which tells me if I take 0 and multiply it by any other number, I still get 0, right? So the only time this works to break it up is if it's 0. So I cannot move the 2 over and factor the way I've been factoring. Okay? What if, let's think about the same thing we sort of thought about earlier. What if instead of cosines we just had x's, right? This would be x squared minus x plus 2 equals 0 if it were x's instead of cosines. How would I factor that? Yep. Wait, hold on. Oh, I messed up. That 2 should be negative right there. I didn't change its sign when I moved it over. Yeah, that does not work because I had the sign wrong. Let me fix that over here. If this is a minus 2, it works though, right? And it should be a minus 2. Okay, so that is how we would factor it for if it was just x's. Very similar if it's cosines. You're going to have 2 sets of parentheses. You'll have a cosine theta here and a cosine theta here. You are multiplying to get a negative 2. You're adding or subtracting to get that negative 1. So you could do a plus 1 here and a minus 2 here. Everybody okay there? And then so once we do that, we set each one of these equal to 0. So I'll have cosine of theta plus 1 equals 0, which is going to give me cosine of theta equals negative 1. And over here, I'll have cosine of theta minus 2 equals 0, which will give me cosine of theta equals 2. Where does cosine equal negative 1? Cosine is your x-coordinate. It's pi. So theta will equal pi. Sine will equal negative 1 at 3 pi over 2. Where does cosine equal 2? It doesn't. What's the highest cosine ever gets on the unit circle? It's at 1, right? Because the radius of that circle is 1. The highest you ever get is 1. What's the lowest you ever get? Negative 1. So you're not going to get any answers from this. We set it up correctly. That part of the problem just does not give you any answers. Yes.
So I know that the domain on that is restricted. If the domain wasn't restricted, could you just go around the circle again and say that it's like
You mean to get cosine of theta equal to 2? No, because like as you go around, it doesn't like add up, right? So if we did like, for example, if we did like at pi over 2, cosine equals 1, right? If we went around the circle again, it would not equal 2. It would just equal 1 again. If you think about the wavy graph, right, it just keeps giving you the same numbers out over and over again. And so if you just have a regular cosine graph that hasn't been like expanded any, it's never going to be 2 at all. So you're throwing it out whether it's restricted domain or not. Okay, so notice the difference here. I had just a single number here. I couldn't do a greatest common factor, so I had to factor with my 2 parentheses. Whereas on some of these other ones, like 19, you're going to have a greatest common factor, so you can pull that sign out for that. Okay, questions? All right, we are going to, okay, so for this problem, for this part of 310, we're looking at inequalities. And a lot of things about inequalities are going to be the same as solving equations. But we will see some differences in what we're looking at. This very first question that he gives us really goes back to some of the very first things that we were doing in this class. He gives us a graph. He says the graph of f is defined from negative 2 pi to 2 pi, as shown. What are all the values of x for which f of x is less than or equal to 10? Now, he didn't give us an equation for this at all. What is the equation for that graph, though, if we wanted to know? What is that the graph of? Yeah, y equals 2 sine, right? It's got a 2 in front of it because its amplitude is 2, but it's not been shifted left or right any, so this is just y equals 2 sine. But you don't need to know that to be able to answer the question. Whenever it asks us where f is less than or equal to 0, what are we looking for on that graph? We're looking for where that graph is under the x-axis. So that happens right here and right here. And whenever we report this, it wants us to give the x values where this happened. It's the domain where it happened. So for that first part, what would that domain be? Okay. Negative pi to 0. Do I use parentheses or brackets? Okay, why brackets?
Well, I just saw that.
Right. That's exactly right. It's or equal to right here, so we want to use brackets. If that was just a less than, then we'd use parentheses. Okay? And then, what's the other part where we're below the x-axis? Pi to 2 pi. So, pi to 2 pi. And they have restricted us from negative 2 pi to positive 2 pi, so we would not go outside of this. Now, this graph would keep on forever, right? And so you would have like from 3 pi to 4 pi, and then 5 pi to 6 pi, if they asked you to do that, but thankfully they did not ask us to do that here. Okay, so this, if they give you a graph like this, it's really just looking at what's above or below the x-axis is all you're doing for that, if you're doing this with a graph. However, we will not always have a graph. And whenever we're given an inequality and we must do this with algebraically, in general, I don't think drawing a graph like this is the easiest way to do it. Instead, I would use the unit circle like he's going to show you here. So he really like sort of explains stuff here. You can read it if you want, but I'll just sort of explain it as we go. The question is really just this first line right here. What are all values of theta from 0 to 2 pi for which sine of theta is greater than or equal to the square root of 2 over 2? So essentially what we are solving here is just this inequality. We want to know what makes that inequality true between 0 and 2 pi. So the first thing we have to know to be able to answer that is where sine equals square root of 2 over 2, right? So what are the values on the unit circle where sine equals square root of 2 over 2? Pi over 4 and 3 pi over 4. Is sine my x-coordinate or my y-coordinate? It is the y-coordinate, right? Those y-coordinates. If I sort of connect these right here, that is the point where my y-coordinate is the square root of 2 over 2. Like if I marked it on the x-axis right here, that is square root of 2 over 2 on, on the y-axis, right? That would be square root of 2 over 2. Where is sine going to be greater than or equal to square root of 2 over 2? Above that line or below the line? Above that line, right? So that means that this section of the unit circle is where we're going to see sine has values that are greater than or equal to square root of 2 over 2. And if you look at the values, the y values that are there, square root of 3 over 2 is bigger than square root of 2 over 2. 1 is bigger than square root of 2 over 2. This one is another square root of 3 over 2, still bigger than square root of 2 over 2. So all of the values here are greater than square root of 2 over 2. So we're given the theta values where this happens. That's our angle. So that would be from pi over 4 to 3 pi over 4. Brackets or parentheses? Brackets. Because it was an or equal to problem, so we're going to use brackets for that. Okay. Very similar to what we've already been doing, except for you're going to have a range of answers instead of just having the two answers that were given. Like if this was an equal sign, we would have gotten pi over 4 and 3 pi over 4 would be our answers, right? Whenever it's inequality, those are going to be like the endpoints of our range right there. Okay, so let's look at example 3. Example 3 is similar to several you had last night. It says let f of x equal 4 plus 2 cosine x and g of x equal 3. What are all values in the xy plane from 0 to 2 pi for which f of x is less than g of x? Last night, you had similar expressions, but there was an equal sign in between that f of x and g of x. Now, we just need to take f of x, plug it in over here. We need to take the g of x, plug it in over here. That will look like this. 4 plus 2 cosine x is less than 3. Okay, and up until we get to the end, we really just solve this like we would solve an equation. We're going to subtract that 4. We'll get 2 cosine x is less than negative 1. We'll divide by 2. We're looking for cosine x is less than negative 1/2. And so we will be thinking about our unit circle here. And we need to know where cosine x equals negative 1/2. Cosine's our x-coordinate. Where does cosine equal negative 1/2? What? 4 pi over 3 is one of them. 4 pi over 3. And then up here at 2 pi over 3, because here you've got negative 1/2 square root of 3 over 2. Down here you've got negative 1/2 negative square root of 3 over 2. So if you think about those 2 points right there, you sort of connect them right here. This is where your x-coordinate is negative 1/2, right? That's your x-coordinate is negative 1/2 right there. Will the x-coordinate, so cosine is your x-coordinates, right? Will those x-coordinates be less than negative 1/2 on the left of that line or on the right of that line? Okay, the left side, right? So on the left side, all your x values are going to be less than -1/2 on the left side of that line. So that is going to be this part of the unit circle. And we want to give the angles where that happens. So that would be from 2 pi over 3 to 4 pi over 3. Brackets or parentheses. Parentheses on this one because we have a less than sign, so we don't want to include the endpoints there. Okay, questions? Okay, similar question on the next one. We've got an h of x and a k of x. And we want to know where h of x is greater than k of x. So we're going to plug them in. We'll get 3 cosine x is greater than square root of 3 plus cosine x. Well, we've got 2 cosines on this one. That hasn't happened to us yet on these types of problems. What am I going to do? Okay. They do kind of need to go to one side. Is this a problem where we're going to factor? That's coming up, and we're going to have to use that, but not until example 5. Yeah, it would be cool if we could do that, but do you think it's going to work, Joshua? It will not. It would... Joshua, you could drop the cosines like they were logs if you had something like cosine of x plus 1 equals cosine of x plus 5 or something like, well, 2x plus 5. You could drop cosines if you had something like that. But, unfortunately, that probably is not going to happen at all in what we're doing on these. So you could drop cosines, but you can't drop cosines here. This one is a little confusing because it's got those cosines on both sides, but think of this like it's a 1 cosine. 3 cosine x and 1 cosine x are like terms, right? That neither one of them are squared. So I could subtract 1 cosine x and subtract 1 cosine x here. And that will give me 2 cosine x is greater than the square root of 3. And once I get there, what do I need to do? Just divide by that 2, which gives us cosine of x is greater than the square root of 3 over 2, which works great because that's a unit circle value, right? So let's think about our unit circle. We got to think about where cosine equals square root of 3 over 2. What are the places where cosine equals square root of 3 over 2? Pi over 6. So at pi over 6, you've got square root of 3 over 2, 1/2, and 11 pi. Okay, sorry, let's do 11 pi over 6 over here, and then over here, we need to do square root of 3 over 2, negative 1/2. Right? So on the unit circle, we're thinking about these places right here. This, like our x coordinate right here is square root of 3 over 2. We're looking for where cosine is greater than square root of 3 over 2. So will that be to the left or to the right of that vertical line that I have right there? It's to the right. So we are looking at this piece right here. All right, how do I write my answer? Is that right? Oh. If I start at pi over 6 right here, and I go to 11 pi over 6 right here, is that what I'm looking for? It is not. That is what like, you're using the right numbers, but that would be the opposite of what you're looking for. That'd be the answer if it was less than. That's not it. can I do that? 11 pi over 6 to pi over 6. When you do intervals, are you ever allowed to have the bigger number on the left side? Like if I did 8 to 2, would that ever be right? No. Can't do that. If negative pi over 6 to pi over 6 would be okay under certain circumstances, but what did they tell us we have to look at? 0 to 2 pi. So we can't use negative values, but it would negative pi over 6, 2 pi over 6 would give us the right part of the unit circle, and if they had not restricted us to 0 to 2 pi, that would be okay. That's better than what we've tried so far, but still not okay because they told us we have to go 0 to 2 pi.
0 pi over 6 and 11 pi over 6 to pi.
Yes, 0 to pi over 6 and 11 pi over 6 to 2 pi. You have to split it up because since they told us we have to go from 0 to 2 pi, what you want to do, since 0 falls like halfway between right here, you're going to start right here at 0 and go up to pi over 6, and then you don't want to include anything from pi over 6 all the way around here to 11 pi over 6, but then 11 pi over 6 to 2 pi. You're going to include that as well. So this would be how we would write it. It's not very tricky if it falls between values on the unit circle like we saw in example 2 and 3. But if 0 ends up in the middle of your segment, you're going to have to split it because you got to start at 0 for that problem. Does that make sense? Why we've got to do that way? All right. Okay. We may only have time to do one of these, but we are, as Isabella had suggested earlier, we are going to have to do some sign chart sort of problems here. This will not be on none of the inequalities will be on the quiz tomorrow, but definitely something we still need to learn. So let me just remind you of when we did the sign chart stuff. It would be like if we had something like x squared plus 3x minus 4 is less than 0. All right, so this is just a review. This is going back to stuff that we did when we used the sign chart. You can't really just solve that the same as if it was an equal sign, right? You would still need to factor, and you would get x plus 4 and x minus 1 is less than 0, like that. But this is more complicated than just saying x equals negative 4 and x equals positive 1 for that. You would still need x equals negative 4 and x equals positive 1 as your test points. But you would need to make a sign line for that. And you would put negative 4 and positive 1 on that sign line, right? And then over here on the side, we would put x plus 4 and x minus 1, and then we'd have a line for our answer. And we'd make that chart that we've made several times, right? And so if I plugged in something like negative 5 plus 4, that would be negative. If I plug in something like negative, or I could put 0 right there, 0 plus 4 would be positive. We'd get a positive here. Then if I do this line, I'm going to get negative, negative, positive, which means my answer, if I've got a negative and a negative, that would give me a positive in that answer line. This will give me a negative in the answer line. This will give me a positive. Which ones would be my answers, the positives or the negatives? The negatives, because this is less than 0, so that tells me I'm looking for the negatives. So right here would be my answer, and I would have negative 4 to 1 would be my answer for that. Okay, so that's review. That's what we were doing when we did this with quadratics, right? It's going to be very similar, just a little more difficult because it's unit circle values whenever we're doing things like example 5. Okay, so we still want to move everything to one side. We want to factor, right? What would I do to factor 2 sine squared theta plus sine theta? Pull out the sine. So I'd have sine of theta times 2 sine of theta plus 1 is less than 0. And then for your test points, not for your answer, but your test points, you would need to set each one of those equal to 0. So sine of theta would equal 0. Where does sine equal 0? I'm going to draw a unit circle over here because we'll need it. Sine will equal 0 at 0. And I think I heard somebody say at pi. Right, so those are 2 places where we know we're going to have 0 as our value. Then I would do 2 sine theta plus 1 equals 0. That's going to be 2 sine theta equals negative 1. I'll divide by 2. Looking for where sine of theta equals negative 1/2. Where does that happen? 11 pi over 6 is one of them. Where's the other? And 7 pi over 6. So oh wait, that's 7. This one's 11. And I'm going to put my coordinates here. This is 1, 0. This is 0. I'm sorry, negative 1, 0. This is square root of 3, negative square root of 3 over 2, negative 1/2. And this is positive square root of 3 over 2, negative 1/2. All right. And if I wanted to, I could like right here on that y-axis, this is where y equals negative 1/2, right? And then this is where my y equals 0. That might come in handy here in a minute because we're going to do something a little bit weird. So these are my test points that go on my sine line. So my number line that I'm going to put right here, I want to start at 0. I want to go to 2 pi. So think about going around the unit circle. The first one we would have would be pi. Then we would get 7 pi over 6. Then the next one would be 11 pi over 6. And then we would be back to 2 pi, which would be 0. And so we're going to put our factors on the left side. We'll have sine of theta. We're going to have 2 sine theta plus 1, and then we'll have our answer line. Sine is not that bad to do. 2 sine theta plus 1 is a little confusing. But let's work with sine first. So from 0 to pi, sine is my y-coordinate. Is my y-coordinate positive or negative between 0 and pi? It's positive, right? Because in first and second quadrant, your y-coordinate is going to be positive. Okay? And then in the third quadrant and the fourth quadrant, is my y-coordinate positive or negative? It's negative. So everything else here is going to be negative. Because from pi all the way to 2 pi, that's the third and fourth quadrant, and the y-coordinate's negative there. So that one is not too bad to think about using the unit circle. I don't like the next one. It's harder. All right, so we're thinking about y-coordinates, right? 2 sine theta plus 1 from 0 to pi. Is that going to be positive or negative? We might have a hard time figuring out, right? So we could pick a value anywhere from 0 to 2 pi. I would probably pick pi over 2. It's an easy one, right? And those are the coordinates 0, 1. So sine of pi over 2 would equal 1, right? Like if we're plugging in pi over 2. So I'd have 2 times 1 plus 1. Is that going to give me a positive or a negative number? Positive number. Right there, so I'll go positive. Now, here's what makes this one so hard. What unit circle value do you have between pi and 7 pi over 6? Nothing. Like, there's none of our memorized unit circle values, right? There are values there at an infinite number of points, but they're not the ones we memorized to be able to do the problem. So let's just skip it for right now. We're coming back to it. We got to think about it. We got to deal with it in a second, but I'm going to avoid it till the very end. Now, I do know some numbers between 7 pi over 6 and 11 pi over 6, right? 7 pi over 6 to 11 pi over 6, I know several unit circle values. So I could pick anything. I'd probably pick 3 pi over 2 because I just think it's an easier point. That's 0, negative 1. So if I do 2 times negative 1 plus 1, that's going to be negative 2 plus 1. That'll be negative 1, right? So that is negative on that interval. And here's our other issue. Do we know any numbers between 11 pi over 6 and 2 pi? We do not. Nothing that we got memorized on the unit circle. So we've sort of got to think about what's going to happen here. If we pick a point that falls like right here, okay, we need to think about our y-coordinates. I don't know what the y-coordinate would be, but I know what it would be between. What numbers is that y-coordinate going to be between? 0 and negative 1/2. So let's pick a number between 0 and negative 1/2, like maybe negative 1/4, right? That's halfway between 0 and negative 1/2. So at that point, I'd have 2 times negative 1/4 plus 1. That would be negative 1/2 plus 1. That'd give me a positive 1/2. That's going to be positive. And it's going to be pretty much the same thing on that other side right there. Because over here, what's the y-coordinate right there if I pick that point sort of halfway between? My y-coordinate would be still negative 1/4 right there, right? So it would be 2 negative 1/4 plus 1 again, which would give me negative 1/2 plus 1. So I'd get a positive here as well. So those are a little tough because you don't have numbers you can plug in, but you can kind of reason through it. So once we have all of that in, we're going to look at our lines. This will be positive for our answer. This will be negative, positive, negative. Which ones are the answers, the positives or the negatives? The negatives, because it said less than 0, so that's negatives. So my answers for this, I realize I'm using all those space for example 6 because I've ran out of room, would be from pi to 7 pi over 6. Would I use brackets or parentheses? Parentheses because it's a less than. And then I'd have 11 pi over 6 to 2 pi. And that would be my answer for number 7, or number 5 right there. Okay, we'll work on that a little bit more tomorrow after your quiz. It won't be on your quiz. Tonight, what I want you to do, even though I just got an email about this. Yes, okay. Yes, it is. Okay. I had it password protected, but I think I've got it fixed now. On your Delta Math, let's see. Oh, wait, wrong thing. Sample student page. On your Delta Math, practice quiz 310, I want you to work on it for 15 minutes, okay? We're going to spend some time working on it in class tomorrow as well, so you don't have to do the whole thing. It'll tell me how long you've worked on it, so work on it for 15 minutes, okay? Yes, yeah. So I'd like for you to do a little bit of it because I'm afraid it'll take too long and then we'll run out of class time. But work on it for about 15 minutes tonight. You'll have some time to work on it in class tomorrow too.